this is a quick video for Chapter 9 Review Prob and Stats. And it goes for assignment number 10 and number 11. Assignment 10 is going to be a review packet. Assignment 11 is going to be that actual Chapter 9 test. When you get finished with them, you just have to send the picture to me. Going over this pretty quickly. Types of correlation: positive correlation, negative correlation, no correlation. Those are the three basic ones that we went over. Also be able to tell if it's strong positive correlation or strong negative correlation or weak positive or weak negative. I have some idea about that. Second thing here, be able to make scatter plots. Make sure when you're making the scatter plots that you label your sides. Also know that sometimes on your scatter plots you're going to have to put that little Z there at the bottom if you're not going to just go the same all the time. If you're going to start at 100 or something and go 100, 110, so on, you might want to put that in there. It's just telling somebody that's been smashed down that you're not showing the entire graph. Be able to write equations for regression lines. Know that regression lines are also called line of best fit. When we write these equations, we're going to use our calculator. On our calculator, we're going to go to stat. Well, first, before we go to stat, you're going to put your list in. Remember, you got to put X in like list 1 and then Y in list 2 or something like that on your calculator. Then you go to stat. Then you go over to calculate. So I go to stat, I go to calculate, and I go down to linear regression, AX plus B. Again, I don't know if all your calculators show the exact same thing, but make sure you're going down to the linear regression. Go down to the first one, not the second one. I don't really think it matters, but just in case. Remember this A, that's your slope. The B is your y-intercept. It's where the line crosses the y-axis. And then you're going to write your equation, and your equation is just going to be y hat equals A times X. You're going to put in whatever the calculator told you for A there, plus B. Might be minus B if it's a negative. Your calculator, when you do all this stuff, and you hit linear regression, you hit that, then you got to put in it'll pop up on your screen, and you'll have to put in like list 1, comma, list 2, then you hit equals. Your calculator should pop up A equals, B equals, then it'll pop up R squared equals, and R equals. If you've done everything to your calculator like you were supposed to do back at the start of this chapter, so if it's not showing you the R squared and the R, then you need to get with me and I'll explain to you how to make sure it's showing you the R squared and the R. You can call me or email me. But this is then you're just going to take A, stick it in there, take B, stick it in there, and that's your equation. Next it says find the correlation coefficient. Well, that's your R, that's right here. So you're going to have that answer from your calculator if you do all that previous stuff right. Then it says determine if there is significant correlation using R and table 11. This is the one where you're going to set up R goes here, and you got your little circle like you were back in 3rd or 4th grade where you're going to put the alligator mouth, and then you have your number from your chart. On the other side, if R ends up being bigger than the number from the chart, then yes, there is significant correlation. If R ends up being smaller, then no, there's not significant correlation. On your chart, you're going to use table 11. And for table 11, you need to know N, which is the number of items in your set of numbers. That's just how many X's or how many Y's. They should be the same. And then they're also going to tell you an alpha. And remember, your alpha is your level of significance. So they'll tell you something like, I think for these we only had 2. They'll tell you like 0.05, so you want a 5% level of significance, or I think the other one that they use was 0.01, a 1% level of significance. So you're just going to determine that. The interpret part, I'll go over that on another slide. Be able to find your coefficient of determination. That's your R squared. Well, if you did everything right on this other stuff, it's going to tell you R squared there, so that'll be that, and you got to be able to interpret that. We'll talk about that on another slide. Be able to find your SE, your standard error of estimate. I'm going to erase all this. To find that standard error of estimate, you're going to have to make the chart. There's no easy way around it. You still want to put all the numbers in your list on your calculator, so you want to put all the X's in the list, all the Y's in the list, because it's going to make stuff easier to do all the other stuff. With our chart, we're going to put X, then a Y, then we're going to put Y hat. That's probably the hardest one. That's the one where we have to plug into the equation that you may have to find. So we got to plug into that equation and determine what our predicted Y's are. Remember, Y hat means the predicted Y for each X. Then you're going to take this column minus this column, so it's just Y minus Y hat. And then you're going to take those answers and square each one. All we really care about on this chart to find the standard error of estimate is this last column here, actually the sum of the last column. That's the number that we need to know. So all the rest of it doesn't really make a whole lot of difference, but that's the number that we need to know. I'm going to erase this, but that's what the chart's going to have to look like. And then we're going to use this formula. That number that we just got off the chart goes right there. That's the number from the chart. And we just divide that by n minus 2. That's our degrees of freedom. N stands for how many numbers are in the set. And then we take the square root of that answer. That gives us our standard error of estimate. We're going to have to interpret that. I'll explain that on another slide. Then the next thing that we did was construct a prediction interval. Remember, it's just Y hat minus E is less than Y, which is less than Y hat plus E. So you're making an interval for what the actual Y should be, what range it should be in, and you're going to be able to say, like, I'm 95% confident that it's going to fall in the range of, from 5 to 13 or whatever. And we'll talk about that. That's the interpretation of it here. But to do this, you got to find E first. E is your margin of error. With the margin of error, you're going to have to know SE. So that means you're probably going to have to do all this stuff up here to find SE so that you can stick it in there. We got to know all this other stuff too. This stuff, well, let's do X over here first. That's the value that you're predicting at. So they'll give you that value. The rest of these, if you stuck all your stuff into a list, it'll tell you what X bar is. You put that number in there. It'll tell you what the sum of all the X's squared is. You put that in there, and it will tell you what the sum of all the X's is. Then you have to put it in there, and you got to remember to square it. N, again, is just the number in the set. So all of this stuff you can get right off the calculator, except for X sub 0, which is the value that they're going to tell you. SE we'll get from right here. We have to do this formula again, or have to do it for that certain set of numbers. our TC, this is our critical value. The critical value use chart or table 5, which is the T chart. And to do table 5, they're going to tell you a C, so they might say like the confidence level that you want is 95% or 0.95 or whatever. Use that number. And use your degrees of freedom, your DF. Remember DF for these is n minus 2. So you use those two things and you look up on the chart, and that's going to tell you your critical value that goes in there. So there's a lot that goes into that, but most of it's fairly easy if you put everything into your list on your calculators correct, and then you just have to do the math. The other thing you got to find is you got to find your y hat. That's what y is. So you're going to have to, if they tell you the equation, then you just plug into it. If they don't tell you, then you're going to have to figure out the equation and then plug in the x sub 0 that they give you. So you're going to, because that's where you're predicting at. So you're going to have y hat equals whatever your a is times your x sub 0 plus whatever your b is. Again, these two things are going to come off your calculator if they didn't give you the equation. So once you do that, you plug in x sub 0, you figure out what y hat is, then we can plug in here. You can plug in y hat here, plug in e here. You're just going to subtract on this side, add on that side, and it's going to give you your interval, and you're saying that you are whatever confidence level, 95% sure that y is going to fall within that interval, within that range. We're going to do the interpretation on another slide again. Predict y hat using multiple regressions. All this was that last section, and it was fairly easy. And all you're going to do is you're going to stick in however many x's they tell you. They're going to have a linear multiple regression equation, and it's going to look something like, it won't look like that. Y hat equals b plus m1 times x1 plus m2 times x2 plus so on, so on, so on, so on. And however many x's there are for that equation, you're just going to take their equation and you're going to plug in here, plug in there, and predict what y hat is for those certain things. Those aren't all that real difficult. All right, to determine if there is significant correlation using R and table 11 to interpret it. This is the one where you use, so you use R. Use R and the alligator mouth, and then a number from table 11. On table 11, you're going to have to use, the alpha that they give you and your n, how many numbers are in the set. And again, I'll attach a table 11 on Moodle, or you should have one that I sent out the other time. So you're going to use those two things, find your number from the chart, and if R is greater than it, then you can say yes, there is significant correlation. And the way you're going to interpret it is just sort of in this method. You're just going to say there so you're going to say there is, and I'm not going to be real picky on this stuff, but significant correlation, because I wasn't real picky with it, as we were doing it throughout the chapter. I wrote it wrong already. That's not what I meant to say. There is evidence, sorry, I forgot this first part. At whatever alpha is, whether it's 5%, 1%, whatever it happens to be. So at a 5% level of significance, sorry, I'm going to abbreviate some of this, and I really don't care if you do it on the test also, even though I've told you not to do that in the past. At 5% level of significance, to say there either is or is not significant correlation between, and I'm going to write it this way, but you got to relate it back to the problem, between whatever they tell you X is. So maybe number of hours watching TV and whatever they tell you Y is. I just remember that problem. It was hours watching TV was X, and then Y was GPA. So you stick in those things there. And that's just how you explain it with that one sentence. Again, I'm not going to be a real stickler on this on the test, but you should be able to do it. You got to be able to explain stuff, especially for the rest of your lives. You're not going to be able to just get away with just giving an answer. Next one, find the coefficient of determination, which is R squared, and interpret that. The interpretation of the coefficient of determination, remember, is just the percentage. So you can say just about whatever the percentage is, we'll say 80%. 80% of variation is explained, and I'm going to stop there. That's going to be good enough for me for that part. But that also tells you got to tell the rest of it also. If 80% is explained, then that means that %, of the variation is unexplained. This video would take about half this time if my pen wasn't messing up. All right, for standard error, once you have your standard error and everything to interpret it, it's just going to be the standard error of estimate of, and you stick in whatever Y is, whatever they're telling you that Y stood for a specific, and then you put in whatever they tell you that X stood for, is about, and then you give the number that you got when you did the standard error formula. So that's how to interpret the standard error of estimate. That's the sentence that you use. And the last thing, constructing the prediction interval and giving the interpretation. So once you've constructed your interval, you'll have something like, we know y is between 5 and 13, whatever it is. It won't be that easy, of course, but once you constructed that interval, then to interpret this, the first thing, to construct the interval, they had to tell you, you had to use it to find TC, your critical value. So they had to tell you a level of confidence, so whatever your C was, and most of the time it was like 95% or 99% or whatever. So we got to have that, because we're going to say that we can be 95% confident that, and then we're going to start putting in what they tell us in the problem. So we'll say something like when, and whatever your x is, this is where you're going to put in whatever x stands for is, and then they're going to give us where we're predicting at our x, that's our x sub 0. So you can be 95% confident that when hours of watching TV is 7 or whatever for the x sub 0 there. Then you're going to say then the whatever y is between, so you put in whatever y is there, whatever, not just y, you put in what y stands for in the data is between, and then that's where you put in your two numbers from your interval. So in my case here, we'd say like 5 and 13. So we can be 95% confident that when x is whatever it is that they tell us, then the y is going to be between your interval there, 5 and 13 or whatever the interval came out to be. Again, I'll probably make a video just to make sure that you understand all this instead of just sending around the key. I'll make a video for the review packet.